All right there, junior physicists. I realized that things were a little chaotic and I'm not really happy with the way a couple things went this week. So I thought I would make this video explaining the ticker tapes a little bit more just in case you had some issues. So bear with me here and I'll try and take you through this a little bit. So a ticker tape is basically almost a machine, almost like telegraph, old-fashioned thing that would just vibrate really fast at a very fixed rate. Okay, most of them make like 40 to 60 dots a second or so. We're going to pretend that ours makes 1 dot every second just to keep things simple. And so if as the thing is vibrating, if I exaggerate here, it's tapping, 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 and the paper starts to move, the dots are going to get spread out, and that's what happens here. So what we do is we tape one end of the paper to a car and have the car start pulling it, a battery operated car, of course. Then we get these dots. So what we're going to do is assume that it starts at the left side. So we're going to say this is time equals 0, this is time equals 0. And remember that every dot is a second. So this first car goes 1, 2, 3, 4, 5, 6 seconds before it reaches, let's say, the finish line, whatever. Whereas this car goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 seconds before it hits the finish line. Now, just thinking of it that way may help you to think about, what this first question is asking. Compare the distance between the dots in tape 1 and tape 2. Well, clearly, tape 1, the dots are more spread out. So what does that indicate? Well, remember, we're talking about kinematics. We're talking about motion, okay? So if it's moving, if the dots are spaced out more, that means that the car is moving further in 1 second here than it is there. Okay, so we can infer that the car pulling tape 1 is going faster than the car pulling tape 2. So that's what we're talking about here. Now question 2 says, use a ruler and measure the distance between the dots for both tapes. Are they consistent? All right, so let's take a ruler, put it down here, and my first dot's about 1.5, it's almost 1.6, so if you want to say 1.55, that's up to you. The next one, I'll move it over. Again, kind of in the same area. The next one, yeah, pretty much still in the same area. Okay, so those are pretty consistent dots. Okay, what about here? All right, well, let's see. So the first one's around 0.8. The next one's around 0.757. The next one seems to be back a little bit closer to 0.8. We're definitely relatively consistent, but not exactly consistent with this. But good enough to say that the speed of this car seems pretty consistent. The speed of this one seems very consistent. Okay, so that's what we're talking about here. All right. So now question 3 is asking us to calculate some speeds. Okay, remembering that average speed is distance over time. So we're going to do it for the first 4 seconds and the first 6 seconds for each tape. So I go back to here, I put it down, and I go to 4 seconds. So at 4 seconds, I'm pretty much at 6.2 centimeters. So let me write that here, just so you can see it. So we have 6.2 centimeters in 4 seconds. Now, usually we want to put things in meters, but let's avoid decimals for right now. So 6.2 divided by 4 is around 1.55 centimeters per second. Now let's measure for 6 seconds. And looks like we're around 9.3 centimeters in 6 seconds. And that does also turn out to be about 1.55 centimeters per second. So that's what's going on here and here. All right. So now let's go to here. And in 4 seconds, let's see, we're around 3.1. I guess I'll write it here, 3.1 centimeters in 4 seconds. So that's around 0.775. I'm going to round that off to 0.78 centimeters per second. 3.1, I don't know if that's visible. Yeah, it looks like I've made a kilometer. It's 3.1 centimeters. All right, anyway, let's go on to 6 seconds. So at 6, we're around 4.7 centimeters in 4 seconds. In 6 seconds is around 0.783. I'm going to round it to 0.78. So yeah, I have to round these off a bit to get them consistent, but we do see that we are getting pretty consistent answers for here and here. So the speed is pretty consistent. Not perfect, but then who is, right? Yeah. All right, so now that's the end of section 1. We're going to go to section 2, talk about tapes 3, 4, and 5. Okay. So for each tape, answer the following questions. Are the dots spaced consistently apart? That one seems to be pretty consistently apart. This one, definitely, I can tell you that this and this are way different. Okay, so no, they're not consistently apart. And here, the first 2 dots are practically right on top of each other. And it's definitely getting bigger spacing. They are not consistent. So what does that mean about the motion? Well, this one is consistent. And consistent motion would really mean constant speed. So I know this object is moving at constant speed. This one seems to be getting a slightly bigger spacing as we go along. Again, if I were to measure, okay, we'd see the first one is around 0.5 apart. If I jump out to here, we're around 0.7 apart. If I jump out to here, we're almost 1 apart. And at the end here, we're around 1.1, 1.2 apart. So clearly, distance is increasing up in this one. And if the distance is increasing every second, then that means the speed is increasing as well. And the word for an increasing speed is an acceleration. So we could say that this car is accelerating. Well, if this car is accelerating, this one definitely is. Because again, these first 2 dots are so close together, I couldn't even possibly measure them on this. I mean, I guess I could estimate that it's around 0.1, maybe 0.05 of a difference. Whereas here, it's a huge difference, way bigger than the distance up here. Okay, so this one is definitely also increasing in speed or accelerating. So now what we're supposed to do is create this table in Excel and go through and start measuring distances for the first 6 seconds. So I'm going to come back to my tape here for a second and number 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, and 6. Okay, so then I'm going to go through and I'm just going to measure the distance from 0 to 1, 0 to 2, 0 to 3, 0 to 4, 0 to 5, 0 to 6. And I'm going to put that into this part of the table. Then I'll do the same thing for tape 4. Then I'll do the same thing for tape 5. Okay, and when I say I really mean you because I've already done these things. Okay, so you're going to make a graph. And you can graph all of them at once. They'll all appear on Excel at the same time, and that's fine. So you're just going, once you put in the data, you're going to highlight the whole thing and go to Insert Graphs and do an XY scatter plot and just let it go. Actually, you could even do a smooth scatter if you want the line to appear. We're not worried about doing trend lines or equations or any of that stuff like we did in the last lesson. Okay, so don't worry about that. And then what does the shape of the graph indicate about the motion? Well, we already talked about what the motion was. So what you're trying to understand is how these different shapes that are going to appear relates to the fact that we said that tape 1 had constant speed, whereas tape 2 had a slight acceleration, and tape 3 had a bigger acceleration. Okay, so that's really what you're trying to relate it to. Then you're going to come down here, and instead of measuring the distance from 0 to 1, 0 to 2, 0 to 3, you're just going to measure distance between consecutive points. So from 0 to 1, and then from 1 to 2, and then from 2 to 3, etc., all the way up to 5 to 6. Okay? Now, really it's saying figure out the average speed. Well, average speed is distance or displacement. Well, we're talking speed. Distance over time. So each of these times is exactly 1 second. So if I measure the distance over 1 second, I found the speed. So you're going to now go back and find the speeds, okay, and do the same thing, fill it in, make a graph in Excel with all of them, and then answer the same essential question down at the bottom. Are the graphs the same as before? Should they or shouldn't they be? How does the shape of the graph now compare to the motion? Okay, I'm not going to answer that question for you. I'm just trying to explain what you need to do here for this assignment. And then finally, the last thing is not graphical, okay? Now it's just looking at the dots and saying, what does car A seem to be doing? And keep in mind that a couple of the cars may have more than one thing going. So they might be doing one thing for part of the time, something else for the rest of the time. So you need to consider the whole tape and talk about it, okay? So you're just going to say A does this, B does this, C does this, D does this, E does this. And done. All right, I hope this helps to explain it a little bit. If you're still stuck on the assignment, let me know. I extended the due date on it because of the confusion. All right, take care, guys.